Hello everyone, good day. My name is Reza Pahlawan, and in this occasion I would like to present to you an overview of my final project topic, which is logistic regression. As K-pop become more popular globally, the investment on this industry become more attractive. Admit it or not, it is a good prospect, especially if the group you are investing in is promising, whether because they are talented or good, or just because they came from a good agency like SM Entertainment, YG Entertainment, and so on. Generally, we can say that a group is successful after they got a trophy in a music show for their release. It's like the lowest bar. Back then, it's easy to predict which group will win. However, after the BTS success, the K-pop industry has become more like a competition. Which group have the most achievement? Like for example, like you can see the difference between G and then wannabe. Like they are almost like 10 years apart, but G has more win than wannabe. Like because of this, like you can see that the investment on the K-pop industry has become more volatile. Like it has a bigger risk now. But we can actually predict whether a group release will produce a winner or not by modeling its probability using logistic regression based on some predictors like their number of views or just like album sales or etc. Deeper into the logistic regression, our response has two possible outcomes, win or not win. Therefore, we can say that it has a Bernoulli distribution. Assuming there is a linear relationship between the predictors and the log of odds, what we are trying to model has this form, this equation right here. In the context of generalized linear model or GLM, logistic regression is a type of GLM with the logit function as its length function, which is a function of the mean of the response. Therefore, in the end, our final model will give us the probability of an event happening based on our predictors. Not only does our music showing, the application of logistic regression is endless. Think about it. Basically, you can modify any event out there into having only two possible outcomes. Okay, these are some past studies that I've found. You see, it can be applied in many different fields, from finance, sociolinguistic, and etc. One thing that I like from logistic regression is that the method of examining the goodness of fit of our final model is simple, easy to understand, and different with any other GLM. Like intuitively, a good model should be able to predict whether that certain event will happen or not correctly by setting a threshold or just like the lowest probability that certain event will happen or not. We can determine them by comparing the output of our model, like based on our predictors of course, with the threshold. We only need to use the concept of proportion, which is sensitivity and specificity here. Of course, we want both of them to be 1 or having 100% probability that our final model would be able to predict an event correctly. However, that's actually impossible. So instead of setting only one threshold, we need to consider every threshold, which ranges from 0 to 1. After that, we can plot 1 minus specificity over sensitivity and get a curve, and which we will call it our OC curve. And after that, we need to calculate the area under the curve, and a good model should have area under the curve near 1. That's all from me. I hope my presentation will give you a broad idea about my final project. Thanks for watching and see you next time.